Okay, in this process, we're going to show you how to calculate volumes for an abutment. In preparation, what I did, I created just a 2D file in which I just reference the existing ground that was given to us. And there is also a single element that traces the bottom of the abutment in 2D. I know that the elevation, as I checked, is 948.6, but this element is in 2D, has no elevation, it's just a microstation element. So what I'm going to do in this microstation element, using the OpenBridge modeler civil tools, I'm going to make this element a feature element, a civil element, a geometry element, an alignment. So there are many different names that you can use, but then let's set the feature definition for that. So let's do this. Let's make it an alignment. Apply a certain feature to it. So let's select that. So just a concept of featureize on this. Let's call it this feature, geometry temporary. Let's put it a certain name, or we can call it abutment too. Right? So that's going to be the name. So locate the element. Yes, is that element. Reset to complete. So it's right click. So this element should become now a geometry element. Let's see. Let's reset to complete just to double check. Let's see if it has created geometry. Yeah, as you can see, it has a feature now. So it's a civil element right now. So the next step is to assign an elevation to it. Remember, this is a 2D file, but we can see it in 3D if you let me right click, view control to the plan view. It splits the views. So I have my ground in 3D, of course, but also I have this element at the bottom because it's in 2D. So let's assign an elevation to it. So assigning an elevation, also making a civil element, let's call it a profile if you want as well. Let's the easiest way, profile by a constant elevation. That constant elevation, as I know, is the elevation at the bottom of the abutment that I just typed, right? Same feature and same name. So locate first element, right? Accept it, reset to end. Click, assign that elevation, yes, left click, that's it. So now these become a civil element, and as you can see in my 3D view here, it has a certain elevation. Just to double check that, I can go spacebar, my selection set, and see if this has generated a profile. Let's open it in a separate view right here, and it should be perfect. So now this abutment has an elevation to it, right? So that would be the first preparation step for that. Okay, so now the next step is to project this abutment to the ground to set up the excavation. Right? So the tool to use will be the slope to target. We just examine the tool. So basically is the slope from the terrain option and at a certain slope cut and fill. So here you got it in percentage, right? The file is set up for that. I like also ratio 2:1, 1:2 slope, right? So in order to change how you enter slopes, just to let you know, you can do it here. It's set up in the file itself. Again, it's just a matter of preferences. So I can go settings here, file, design file settings, look for the slope format. Percentage. No, I want ratio. Ratio, run rise. Right? So it could be, again, depending on. So run 1, rise 2, for example, 1 to 2 slope. Some people call it rise run. 2 to 1 slope. You're used to that. So, again, it's up to you. So they will, let me do it like, right? Run rise 1, 2. Run 1, rise 2. So again, it's part of the file now. So let's come back to it. So now let's do the two. Right? So slope to target. You see? Now to terrain model. Let's go 2 to 1 slope. On cut and fill, I'm just going to put it like that. I don't know if the slopes are cut or fill. Usually it's fill, right? So constant slope, there is no transition in between, around it. And it's going to be all the way to the beginning, all the way to the end, meaning all around the structure. Right? So we'll just go. Select the tool, right? To a terrain model. It will be that terrain model here, right? Your. So, yes. Locate reference element. So that will be my bottom of an abutment that has a profile already. Locate reference element. Select the terrain. Yeah, because I didn't set up an active one, so I just selected the ground. Cut and fill, yes. Left click. The slope is going to be to the outside, yes. From the beginning, yes, all the way to the end. Data point to accept the design, and that will do it. So just right click to end the command. Also, I left a gap here, not to have a close element, but I can take care of that. Just basically mount this right here, and it will just complete the ground itself. So now, if I can see it in 3D, that is the excavation that it has done. So now, I can fix this as it projected the slope on many different ways. One, to compute now the volume that it has created. So these two elements that I have in 3D right now must become part of a terrain. So I need to create a terrain. To do that, I will create a terrain starting with the bottom of the button. So to do that, I would say create a terrain from elements, and that element will be my bottom of the button. And it's going to be a break line. I'm going to use maximum triangle length, because if not, because of this, it will create maybe a triangle from this point to that point. We can play with our options. Let's do a triangle length, be conservative, 25 feet. I want to see the triangles, so my feature definition will be existing triangles, just to see it. Let's call this abutment, the abutment volume, right? Or abutment terrain, for example. So that's it. I will add this element, just that, as a break line. Accept it. Yes, accept the setup of maximum triangle length. And 25. Let's see what happens. Good enough. I still have some sliver triangles here. But if you want to see the properties, one more time, my space bar, features, and select the terrain and see what options do I have here. You can see that's the sliver method that I selected. Let's see if I type 20, for example, to tie it up. These options. No much. So again, it's up to you on that adjustment. So as you can see, it hasn't created triangles outside. And I have my terrain just at the bottom of the abutment itself. Now, the top is where the full terrain will be created, or added. So in that case, I will just add a new feature right here to that existing terrain, to that abutment terrain that I created. But this element, right, the top slope, it will be the one enclosing the terrain. So the feature definition will be a boundary, right? The terrain, it will be that terrain. So in addition to this one, so that's why locate the terrain modeling to add the elements, that one. Click, right? Sets the ID. The element to add will be that boundary definition that I can select it here in the 2D view or 3D view, whatever is easier. So just add it. That's it, reset when done. So right click. The boundary, yes, click. And now I have my full excavation at a 1:2 slope. So as this become a terrain now, so I can use the options of civil analysis here and just analyze volume. Right? And the analyze volume option, it will be the computation between this terrain against the existing ground. So let's select it, analyze volume. Right? Terrain to terrain model. That's okay. I can do it to a certain plane. So if I need to set up an excavation limit at a certain elevation, I can do that too. So from terrain model to terrain model. So the selection depends how it's going to show, cut or fill. So accept it. So I'm going to do it from this terrain to this terrain. Certain cut and fill factors, save the result, accept it. No boundary, so it's just the full length of the DTM or the ground. Right click, save the result, yes. So I need to cut, as you can see. Let's place the results somewhere here. And that will be the cut that I need to place the abutment. Now we can do more options on that too. I can try different configurations if I need to. So that is, for example, this tool. If I go to my spacebar again and select the boundary definition and properties, let's see what I can have here. I can set it up to a different elevation. Or for example, it could be that the profile itself of this abutment, it's a little deeper now. Right? So I said that, oh, that elevation was not 948. Now that elevation maybe, I don't know, it's 915. So it's going to be a new elevation. Of course, the abutment will go at a different elevation right here. And then all the elements will just get extruded. Right, the 2D element. If we can check it. That's my reference file. Right, so for example here. So I attach as a reference. So this is what the original abutment. Oh, sorry. So let's level display right here on my abutment. I don't want to see the reference. So this was the new abutment. So now see this deeper excavation. and also the different elevation too. I just changed the profile of the element itself. See, as you can see, if I update the profile one more time, it was a 915 now. So the same concepts apply. It has gone 1 to 2 up. So let's calculate the volume one more time. Go to Material Tools, Material Analysis, Analyze Volume. Right, and I will go from this to this new one. And see what I have. So now, look the amount of cut that I have to do when I lower this. This is 275,000, 47,000. Right? So it has gone to the same slope as the element recognizes what it was done. So if I can come back to the same elevation, so let's go back to my selection set and update the profile view. Right here. So now remember that was 90. And the elevation was 948.6. Everything gets moved. And the new element should have that new elevation. Yep. And the ground now should come back to the same elevation, right? So let's see. And civil analysis, let's go volume one more time. From the terrain model right here to this terrain model. Let me see, it went back to the same values. So you can play with different elevations too, and then you have your abutment volume right here, and maybe try a different slope. Well, for that, then you will need to project a new slope.